Hello, everybody. Welcome to our webinar for this week. As always, I'll give it a minute or two for anybody who is running slightly late and would be interested in joining the webinar. Let me just say that in case you were present for our the last webinar, you probably witnessed a disaster. For some reason, our streaming software was not behaving well. It was getting stuck again and again. I think that we fixed it. So I'm hopeful that today things are going to be smooth sailing. And so let me remind you that today we're going to talk about how to handle reference objects. And this is a quite important topic because there's several design workflows that you can follow with Phi, and very often users want to start from scratch. So empty screen, start with a basic object and work from that to create their design. But sometimes, first of all, it's very useful to be able to have some images, some sketches, like blueprints maybe of an object that you want to design, some product. And so that's one thing we're going to cover today, how to bring in sketches and use them as references. Also, you may want to bring in stuff that you have created within Onshape. So maybe some Onshape part studios, or entire parts. You can bring these in and use them as reference, or in some cases you can also actually convert them into editable Phi models. We'll talk about this. And lastly, very often you want to use some STL model that you have available to you. It could be a 3D scan of an object that you want to use as a starting point. And again, we'll see what tools we have to work from STL. So, given that last week I went through this, obviously with not much success, I think that today I will take things in the opposite order. So I will start from the end, so that if we don't have, if something goes wrong, we will at least have covered the stuff that last week we didn't get a chance to do. So, STL files. Now, as you know, you can start within Phi. So, by the way, here I'm running Phi within Onshape, as always. This is my Phi tab. This corresponds to the Phi application. And so the point here is to see how I can bring in some STL file and use it. So I have already loaded one STL file, which is actually a bone, a scanned bone. You see it here. So I loaded this within my Onshape document. So in this case, I can, for example, load a cylinder into my Phi environment. There it is. And I can also click on the STL button here, and I will get the option to load one STL file. So the bone is the one that I want to load. You can specify the units, because as you may know, STL files are unitless. So effectively, we have to explain the numbers in the STL files coordinates. What do they correspond to? Centimeters, millimeters? I think centimeter will probably work. And let's see. So now it's bringing in this STL file. There it is. And it's displaying it in my environment. First of all, just as with Onshape references that we'll see in a moment, from the settings menu you can specify whether you want these references to be transparent or not. So if I make it transparent, you see it turns to this green color, and there is a bit of shading weirdness going on depending on the triangulation. Anyway, don't worry about it. The thing is that this allows us to see through the objects and makes it a little easier to work with them. And now, once you have these STL files loaded, you can either just use them as a reference. So for example, I can take my cylinder here and I can rescale it and position it roughly there, rotate it, shrink it further, I don't know, something like that. And oh yeah, obviously I have to also move it into place here. So let's say if I could just use this as a starting point for my design work. So for example, I can then select this face and independently shrink it so that it captures the dimension of my STL model, and then I can individually pull out maybe my vertices, you know. So that's one way of doing it. Just use it as a reference. The other thing you can do is if you select a vertex, into the place menu there's this snap button, and if I click it, it will highlight for me all of the vertices of my STL model. And so I can select one of them, for example this one here. There's a bit of a lag in my mouse movement. I hope it's not very annoying. So I select it, and then my vertex snapped exactly onto the location of this STL vertex. Now obviously in the case of a bone, any vertex is not particularly important, but imagine if you have brought in a geometric model, I don't know, a cube or something with specific corners, then you could snap your vertices exactly onto location. So that would be more useful. A disclaimer here, just one point, that in case you have many vertices, I think our threshold is something like 200,000 vertices in your model, then we automatically disable this functionality, because to display 200,000 vertices and also to load the information that will allow us to snap onto them would be too much of a burden for this application in the browser. It will become very slow and sluggish. And also we are assuming that if you have a model with 200,000 vertices, it's extremely unlikely that you'll be interested in snapping exactly onto one of those. So we're thinking either it's a model with few vertices that have some meaning, or it's just a huge point cloud, in which case snapping is not useful and it's not gonna work. So we disable it. All right, now the other thing you can do with of course, from the menu here, you can edit the STL model. So I click to select it, and then as we have discussed in the past, you can use the X, Y, Z buttons to move it, and 1, 2, and 3 to scale it in the three dimensions, or the up arrow and down arrow to rescale it proportionately. And then when I'm done, I exit. Again, there is some lag. Okay, I exit the edit state, so now my model is there. And the other thing I can do is we have a couple of facilities here. For example, sometimes you have a really large STL file and you don't really care about the whole thing. It may be too huge, or you may be interested only in a small part of it to do your work. So in order to help you with that, if we go into the section view mode, which you may remember, this will automatically switch to non-transparent because it's better visualization. And for example, again, I think that this recording is causing some sluggishness. Anyway, so I only boxed a part of my STL file as it is there. Then I can go into my menu here, the STL menu, and click on this icon, which will save a version of this STL file that only contains the part that is inside my section view. So now I'll get rid of the section view, and if I go into my Onshape menu to import, for example, I will import here this, I think this is the, yeah, you can already see there that it's just a fraction of the entire model. So I will just import this into Onshape to have a better look at it. It takes a moment. Anyway, once it's in, I will show you that we have truncated effectively. We have cropped this STL, and there it is, so that only the part that was inside the section view is here. Now you see this segmentation. It's because we probably some of the triangles were just inside and some were just outside the box. We do not create new vertices and triangles to exactly match the border of the section view. I don't think that would be very useful. So effectively you just throw away a big part of your STL file and let you work with the rest. So this is a smaller model effectively. It's just a tool in your STL facilities. And the other thing you can do with this last button here, by the way, let me bring on the tooltips. There it is. So you can see the quick description of these buttons if I manage to. Very big delay. Anyway, I'm not complaining because so far so good in terms of recording. I mean of streaming. So as you see, this will save a reduced version of your STL. So effectively, it's our algorithm for subsampling your STL file. Now, here you have to give it a value. We don't specify what this value corresponds to because it's not something very intuitive. But let's say if the smaller number I give, the smaller number of triangles I will end up with. So if I give it, for example, 30, it's saved into my onto my disk a version. Let me. Sorry. This is painful. Okay, I will try to import this again. No. Okay, import reduced to, I think it was this one probably. All right. So yeah, import, and you will see that now we have subsampled our STL file. So from a large number of triangles, we went down to a smaller. Very, very roughly, this number 30 means that if it were not a bone and it was a box, a cube, it would have 30 rows by 30 columns by 30, again, columns in the other direction, a grid of 30 by 30 by 30 vertices, very roughly. Okay, translated with errors. I am assuming that some triangles got collapsed in the process. Anyway, you see it's a lower number of triangles. It's well, it's our attempt to give you a lighter model to work with. Okay, now more importantly, however, if I manage to work with this slow pointer, I wanted to illustrate something else. So I have prepared a little model to start from and save a little bit of time. So it's this bone serve 3, I believe. So I will explain what I'm going to do here. We believe that very often one thing users would like to do is bring in a scanned object, for example a point cloud like this bone here, and try to replicate it with phi surfaces in order to then be able to edit it, work with it, export it in different ways, create B representations from it, etc. So let me remove the transparency. So what I've done here is I have this bone, and I very roughly, let's say, wrapped it with a cylinder consisting of little facets, as you see there. And my hope is to be able to, I will use the expression shrink wrap this surface, this cylindrical, kind of cylindrical surface, onto my STL model. Because if I manage to do that, then from that I can start editing, for example, rescaling, changing proportions, or adding features, removing features, etc. So within the place menu up here on top, we have this last button that is called Attach Phi Surfaces to STL. And we have a little note here that it's in beta, which means that it works, but sometimes it will give results that are weird. And the reason we haven't developed this a little further is that we haven't found too many users to give us feedback about how they would like to use it in what types of STL scans, etc. So this bone, it's a nice example. It doesn't have too many details on it that we care about. So it will work okay here. If you had another scan with very, very small details, we probably would like to tune our algorithm a little better. So let me explain how this works. First of all, it's all described here, but I will save you the time of reading it. So, and by the way, as always, read more brings in an example, a little video, full explanation. But let me just walk you through it. So first thing you do is you have to select the part of the model that you want to wrap onto the surface. So in this case, everything. So I selected the phi model, the entire number of phi surfaces. And then I go into this little menu at the bottom, this button here. And the first thing it will do, it didn't happen in this case, but if our STL file were a lot bigger and far away from the phi surfaces that we selected, it would automatically delete those parts and only keep the parts that are relevant to what we want to do. That's just a convenience for making things a little faster. Okay, in this case I placed it initially quite close to my entire model, so it didn't do anything like that. And then effectively there are 3 steps, and to execute each step in order you hit the buttons 1, 2 and 3. So I will hit 1, and what's happening now is that it takes each vertex of each phi vertex from this cylindrical shape, and it will try to push it onto the STL surface. Turns out this is not as simple as it sounds, in terms of implementation. You want to avoid protruding STL noise, for example, and have a vertex floating in space. In some cases you may have surfaces that have a ridge, and you don't want to completely miss this feature, so you cannot just go perpendicular towards the center of mass, let's say, of this bone. So it turns out that it's a tricky problem, and we found a way, I think, to give a pretty decent result. So what happened here is that all of the vertices of my phi surface, the visible vertices, were snapped, let's say, in some clever way onto the bone. Now I will hit the second button, so number 2, and what happens here is that now all of the edges that connect these vertices will be deformed to follow the shape of the STL model. And this is not, again, very simple, because we don't want to miss features. However, if we go exactly onto every little detail, every bit of noise, every little hole, then the surfaces that are defined by these edges will be a little messed up. They will be very, very weird. So instead, what we're gonna do is we try we found a middle ground where we try to follow the features of our model, but not really exactly where each facet of the scanned STL model is. And now there's a third button, number 3, which I will press. And what this does is it goes in and does a bit of post-processing. So if it finds little bits of edges that are suddenly turning very abruptly, or 2 edges that are meeting at a very, very sharp corner and things like that, it will go in and it will try to smoothen and adjust them. Again, the goal here is to capture the features of our model without doing something so extreme that the surfaces will then be so much messed up that they're going to be unusable. So this takes a little more time, and actually everything is slowed down because of my streaming software. Again, apologies, but at least so far it's working, so I'm happy about that. And a couple more seconds, I think. Shouldn't take too long. And so now we're kind of smoothing everything. You can skip this last, there it is. And it says down here on the right, it attempted to correct 76 issues. Again. So it means that it found 76 points onto this network of edges that were a little bit off, and it tried to smoothen them. All right, so if I hide my vertices, And I also hide my bone there. Yeah, sorry. Once you're done, you have to hit this, again slow, this little button here. Bear with me. There, okay, so now we completed, we exited this beta mode where we attached the STL. And with a bit of luck, things will move. And now I can go and hide very slowly, very slowly. Oh no. Yeah. So, again. No. Sorry about this, I don't know what to say. Okay, so I was able to hide my bone. And so this is the resulting, this is the surface, this is a phi surface. So one thing I can do right away is hit my little green button here, bone surf 3, and set this to OnShape. So once this is out in OnShape, it will be converted into a perfectly workable OnShape surface, and you can use that and do with it whatever you want. Within OnShape, I mean. It will take a moment now to export, and we'll see it in a new tab at the bottom. Okay, but still, as I'm here, I can, for example, I don't know, shift click. Now shift is not working. Okay. Oh well. Okay, whatever. I selected these edges that you see there, and I can hopefully smoothen them. So I shift clicked on smoothen, so it will keep the vertices of the network in place, but it will smoothen the edges. And I can, for example, now shift works again, perfect. Oh, come on, I will do the same over there. And this will probably give some improvement in the shape, I mean some smoothing, yes. And or for example, you can select a ring here and hit M and inflate it like this. Come on, this is terrible. Anyway, yeah, so suddenly you have a different shape of bone and all of that. So effectively the point I want to make is that once you have imported an STL file and you have been able to attach a phi surface onto it, there it is. I mean, it's yours to use. And let me go to my OnShape tab here, where I have exported it, and there it is. I will hide all the planes. Oh, come on. This is very annoying. Hide all the planes, very good. And I will go in here and I will zoom. And so you see, effectively, you know, I mean, it doesn't look like much and it's not perfect, but we did find a scanned bone and now we have it within our B-rep representation, and it's available for us to use. So I think it's a pretty useful feature, I think. So by the way, since I just presented all of this stuff, if anybody is interested in this kind of functionality, and you have some application that you think, maybe that would be very useful for me, we'd love to hear from you, because this will give us a little bit of feedback and some help in fine-tuning it. There's a lot we can do to make it faster, more accurate, give better results. For example, here you see there's all these linear stretches. I think it's because my initial shape was a little elongated. But actually, if I go back to phi, well, now I changed everything, but just as a last example, and bear with me for the slowness of everything here. So I'm selecting all of these loops of edges and I will shift smoothen them. So with shift, there it is, it will keep the vertices, so the points where the edges cross, everything, all of those points will remain intact, but the edges themselves will be slightly smoothened all around these rings. And as I said, it will take a moment, yeah, because everything is slowed down because of my streaming software. Probably need a more powerful laptop, but let's give it another few seconds. And the point I want to make is I think that the result will be much better. Now I also messed up this bone, I widened the middle just to demonstrate something, but it's okay. Mostly I would like us to have a look at the quality of the surfaces. There it is. So I will send this over to Onshape once again. So if I go back to my Onshape tab here, this is the previous result, but due to our live update functionality, in a few seconds we should see it jump into the new shape. And I'm hoping that we will see fewer of these linear, let's say, ridges that probably are not exactly what we would like to see. And actually I see that I have exhausted my 30-minute window. There it is. Yeah, so I think that this is, this looks pretty much improved. Okay, there's a little fold here. I don't know what caused this, but anyway, I think that's the point I wanted to make. So I exhausted all. There it is. Okay, no, that's my fault because I don't know what I did here. Probably messed up the edges. Anyway, don't worry about that. I think that I will stop here because anyway I exhausted my window. There's no point in going into the images and Onshape importing, but these topics have been covered very nicely by my great colleague Georgia in the previous webinar that you will find on our series of live webinars, and also you will find nice tutorials on exactly these topics. So I think I'm happier about the fact that I was able to describe this STL functionality a little more because the rest is already presented. And yes, as always, I ask if there are any questions. I don't see anything in the chat. So I'm guessing that whoever is watching is happy with all of this. And what else can I say about all of this? I think, since we're here and we have another 2 minutes, to import any reference image, you just click on this last icon here. And there are some images that I have already loaded into my Onshape document. So this is one image. I will give it a width of 10. It will adjust the height to keep the proportions, and I will place this in the front, let's say front view. Still loading. Okay, a bit large, 10 centimeters. Let's zoom out. There it is. And I can then go back here and I can select another image like this. I will place it on the side view and I'll give it again 10 since that's what I did. And it doesn't mean that you can only load one front image on one side. You can load as many as you want. So obviously you can also move them around. So let me demonstrate that. There it is. So I go into the edit mode very slowly today. This little pencil means edit. I click on this image, I hit M for the move tool, and for example I can send this lower down there or even rotate it. I can do whatever I want. And then I can, for example, I can hit here and I can select another image. Well, now I don't have anything else. And if I put it on the side again, side just means place it on that orientation at the middle. So there it is. And I can do this as many times as I want. So basically, yeah, so I think I went over this also. You can use as many sketches as you want as references for your design work. So the only thing I didn't cover today is importing from Onshape. But as I said, that's all covered in our other tutorials and in the last webinar that Georgia did. So I think we're good for today. It's exactly 30 minutes. And so thank you very much for following this webinar, and I hope to see you next week as well. Signing off, and very happy that the streaming software worked at last. There we go. So thank you.